Hello, I see that you have decided to continue your training. A very wise decision, if I do say so myself, and I do. I do say so myself. Today, we begin our second lesson in learning everything you need to know to defeat the binary mermaid, and with that, basic math. Now, I know what you're thinking. How is learning math going to help me defeat some mermaid? What's she going to do? Ask me some math questions? And to that, I would say, you'd be surprised. These mermaids, they are very weird creatures, and my job is to prepare you for anything that might happen. So, this is just what we got to do. Today's lesson is going to be about two things called multiples and factors. I know right now you're thinking, what the heck are those? I'm going to tell you what the heck they are. And by the end of the video, you're going to be going, this is what the heck they are. You might not say the heck that many times, that might just be a me thing. But what I do know is you are going to know what multiples and factors are, how to find them, and how to use them to show your GED Math exam who is boss. It's you, by the way, your boss, in case that wasn't clear. Let's do this.
Okay, so let's start by looking at multiples. So you might be wondering, what is a multiple? And it's easiest to explain by using an example. So, for example, if I wanted to know if something was a multiple of 3, all that means is, does 3 go into that number? So what I mean by that is, if I count up by 3s, can I eventually get to that number? So to give you an idea, let's run through what a few multiples of 3 would look like. So if I wanted to know what the first few would look like, the way that I would figure that out is I would start with my number. So I would start on 3, and then I would just count up by 3s. So I would go 3, 6, 9, 12, 15, 18, 21, 24, etc., etc. I could keep going forever because numbers keep going forever, but that gives you an idea of what multiples of 3 are and what they would look like. So it basically just means, if I count up by 3s, can I eventually get to that number, right? So I can get to 15 by counting up by 3s. That means 15 is a multiple of 3. I can get to 24 by counting up by 3s. That means 24 is a multiple of 3. So that's the easiest way to think about it. If somebody asks you, is this number a multiple of 3? You just think, well, does 3 go into that? If I count up by 3s, can I eventually get to that number? Another way of thinking about it is that number divisible by 3? Because if some number is divisible by 3, that also means it would be a multiple of 3. And then the third way that you could think about it is, can I multiply 3 by some number to get that number as an answer? So what I mean by that is, let's say somebody asks you, is 48 a multiple of 3? You would think, well, you could think about it the first way and say, well, does 3 go into 48? But that might take you a long time to count up. So you could also think about it, well, can I multiply 3 by some number to get to 48? And the answer is yes. You could do 3 times 16. If I did 3 times 16, that would give me 48. I just know that off the top of my head. That's okay if you don't. But that is just another third way you could think about it. In case you don't want to count up by 3s a lot, that might help. Okay, so now let's look at another example. So let's say I wanted to list out the first few multiples of 5. What would that look like? Well, it would be the exact same process as 3s, just we're dealing with 5s now. So I would start with 5, and then I would count up by 5s. So I'd go 5, 10, 15, 20, 25, 30, etc., etc. That gives you an idea of a few multiples of 5. Basically, just counting up by 5s. All of these numbers, 5 goes into, so they are all multiples of 5. Okay, so now that we have a bit of an understanding as to what a multiple is, let's look at something called a least common multiple. This is a term that is often denoted as LCM. So if you ever see LCM on your GED Math exam, that is referring to least common multiple. A least common multiple is basically the smallest multiple that two numbers share. So, for example, let's say they are asking you for a least common multiple to find the least common multiple of 3 and 5. This basically means I want to find the smallest number that 3 and 5 both go into. Now, as it just so happens, we already have the first few multiples of 3 and 5 written out above, so all we have to do is look at both these lists and find the smallest number that is on both lists. Do you see any number that is a multiple of 5 and also a multiple of 3? That's right. If you look at multiples of 5, we've got a 15 over here. And in my multiples of 3, I also have a 15. So, 15 is a multiple of 3 and 5. Is it the least common multiple? Well, yes, because there's no smaller number that is on both lists. So, our answer would be 15. The least common multiple of 3 and 5 is 15. All that means is that's the smallest number that 3 goes into, and 5 also goes into. Right? If I count up by 3s, 3, 6, 9, 12, 15, I can get there. And if I count up by 5s, 5, 10, 15, I can also get there. So that would be our answer. Now, let's try an example where we don't already have those lists written out for us. Let's say they ask you to find the least common multiple of 4 and 6. Again, all this means is I want to find the smallest number that 4 and 6 both go into. And you might be able to figure this out in your head. You might be able to count up by 4s and then count up by 6s and find some number that both go into. But let's just say you didn't want to do that, or maybe you had a headache and you didn't want to do mental math, or you didn't want to take any chances and you wanted a better, more foolproof way to do it. I would suggest writing out just like we did above. Write out the first few multiples of 4, write out the first few multiples of 6, and then see what's the smallest number that both go into. So let's do that. Let's start off with our multiples of 4. How would we start that? That's right. We would start with 4. And then what would we do? Right again. Look at you. Then we would count up by 4s. 4, 8, 12, 16, 20, 24, 28, etc., etc. Hopefully that's enough for us to find some commonality. All right, now let's do multiples of 6. So we start with 6, and then we count up by 6. 6, 12, 18, 24, 30, 36, etc., etc. Okay, now that we've written out a few, let's see, can we find any numbers that are on both lists? Well, I can see off the bat, I got 24 on both lists. So you might think, awesome, that's our answer. Let's write 24, move on. However, you have to be careful, because it's not just asking you for any common multiple, right? It's asking you for the least common multiple. That means we have to check, are there any smaller numbers that are also both on the list? Okay, let's go down the list and see. So 24 is on both lists. What about 18? Do we have 18 here? Nope, no 18. What about 12? Do we have 12 here? Oh, we do. Okay, so 12, that is smaller than 24. So 12 is looking like it might be our answer now. But let's keep going just to make sure. Well, 6 is the last number on this list, and there's no 6 here. So I can confirm that 12 is the smallest number on both lists. That means 12 is going to be our least common multiple. It's the smallest number that 4 and 6 both go into. Right? If I count up by 4s, 4, 8, 12, I can get to 12. And if I count up by 6s, 6, 12, I can get to 12. So they both go into it. It's the smallest number. Therefore, it's our answer. So if they ever ask you to find the least common multiple of two numbers, it just means find the smallest number that those two numbers both go into.
Alright, so this video is a bit of a long one because we are covering two different topics. So I want to give you a short chance for an intermission, give your brain a break, let yourself process all that new information, do whatever you gotta do, run to the washroom, stretch your legs, grab a snack, whatever it is, and whenever you feel refreshed and ready to go, click play again on the video and we will get back to it.
Okay, so now that we've learned about multiples, let's look at something called factors. So, If you wanted to find all of the factors of 24, just using it as an example, what that basically means is you want to find all of the numbers that can go into 24. So it's kind of similar to a multiple because we're dealing with numbers going into other numbers. But I basically want to find all the numbers that if I count up by that number, I can eventually get to 24. Another way of thinking about it is I can multiply that number by something to get to 24. A third way you can think about it is that a factor is a number that you can divide by evenly. So what I mean by that is when you divide with that number, you don't get a decimal. So for example, can we divide 24 by 2? Yes, we can, because if you do 24 divided by 2, that equals 12. It's a whole number for the answer. There's no decimal, so that means 2 is a factor of 24. On the other hand, can you divide 24 by 5? No, you cannot, because if you do 24 divided by 5, you get a decimal as an answer, and so that means 5 is not a factor of 24. So those are 3 different ways that you can think about it. Use whatever way works best with you. Sometimes one way clicks with someone's brain, and another way clicks with someone else's brain, so I just want to give you all the different ways that you could think about it. Use whatever works best with you. So for example, the first factor of 24 would be 1. And I know that 1 is a factor of 24 because I can multiply 1 by something to get 24. Right? 1 times 24 would equal 24. So I know that 1 is a factor. What about 2? Is 2 a factor of 24? Now all I'm asking there, you can either think about it as, does 2 go into 24? Or can I multiply 2 by something to get to 24? I think probably the easiest way to think about it is, does 2 go into 24? If I count up by 2's, do I eventually get to 24? And the answer is yes. We could go through it and go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I do get there. You might not want to go through it like that every time because it might take a lot of time. And the more that you do this, you'll kind of get to know what numbers go into what numbers. You can also use shortcuts. Like for example, I know that 2 is going to go into 20. So I can skip all the way to 20 and then just keep counting up by 2's. Or I can go, I know it goes into 20 and then 22, 24. That's a great way to save yourself time in math. It's just to use shortcuts with multiplication. But anyways, 2 goes into it, so 2 is a factor. What about 3? Does 3 go into 24? 3, 6, 9, 12, 15, 18, 21, 24. Oh, it does. Okay. So 3 is going to be a factor. What about 4? Does 4 go into it? And again, you could think about it as, well, can I multiply 4 by something to get 24? And you might know 4 times 6, that equals 24. And if you're not sure, you can always double check. 4, 8, 12, 16, 20, 24. So 4 is going to be a factor. What about 5? Does 5 go into 24? Well, 5, 10, 15, 20, 25. Nope, that doesn't go in. So 5 is not a factor. That's our first number that's not a factor. What about 6? Well, we already said 4 times 6 gives us 24, right? So we know that 6 is going to go into it because 4 times 6 gives us 24. Okay, what about 7? 7, 14, 21, 28. Nope, that doesn't work. What about 8? 8, 16, 24. Oh, 8 works. And how many times did it go in? 3. Okay, so we know that 8 times 3, well, that's interesting. 8 times 3 also equals 24. All right, now what about 9? 9, 18, 27. Nope. What about 10? 10, 20, 30. That doesn't work. What about 11? 11, 22, 33. Nope. Okay. What about 12? 12, 24. Oh, that works. And how many times? That went in twice. 12 times 2. Oh, look at that. 12 times 2. That gets 24. And, well, 12, that's half of 24. I'll give you a bit of a trick. Once you get to the number that's half of your original number, that's going to be the second last factor. the last factor is always going to be the number itself. So once you get halfway there, right, 12 is half of 24, I know that's it, except for the number itself. I don't have to try 13 or 14 or 15, because I know that if they're bigger than half, there's nothing I can multiply them by to get to 24. And so that would be our last factor. And again, 1 times 24, look at that. Look at that. That works. And so if you factor correctly, you will always get this rainbow shape where your first and last factor, don't know if you can hear that, but sirens just went by my place, so I thought I'd stop for a second. Anyways, your first and last factor will always multiply to get your number. Your second and your second last will always multiply to get your number. And the pattern continues, so you'll always get this kind of from the outside in. You'll always get this pattern where your factors multiply together to get your number. And that's how you can check that you did it correctly. And it's also a way that you can use a bit of a shortcut in the process, because once you get here, and I'll show you this in the next example, once you get here where you know that side by side these guys multiply together, then you know that the next one here is going to be whatever this one gets multiplied by. And then you know that the next one here is whatever this one gets multiplied by, and so on and so on. That might have been confusing, so I'll go through it in this example below. Okay, so those are the factors of 24. Now let's look at the factors of 16. And I've kind of written into my space here, so I'm going to start them all the way over here. Hopefully that's not too confusing. But let's do our factors of 16. What are we going to start with? Well, let's always start with 1. Is 1 going to be a factor? Yes. How do I know that? Because 1 times 16 is going to give me 16, right? 1 will always be a factor. Okay, what about 2? Does 2 go into 16? Yep, it does. I know that because 16 is an even number. 2 goes into every even number that exists. So 2 is going to work. You could always double check. 2, 4, 6, 8, 10, 12, 14, 16. Okay. What about 3? 3, 6, 9, 12, 15, 18. That doesn't work. And again, that's where I would use a shortcut, because I know just off the top of my head, I know 3 goes into 15. So if it goes into 15, I know it's not going to go into 16. So I could also just use shortcuts to save myself some time. What about 4? Okay, so I made a mistake there. I wrote 3. I shouldn't have, because 3 is not a factor. So I just left that in there to show you proof that math teachers also make mistakes. We're humans too. So don't feel so bad about your mistakes, because even the people teaching you make them sometimes. So mistakes are okay. All right, so 3 is erased. He is not a factor. Let's try 4. Does 4 go into 16? 4, 8, 12, 16. Yes, it does. Okay, so 4 is a factor. And did you notice how many times it goes in? It goes in 4 times. That means 4 times 4, 4 times itself, gives me my number. And so the reason that I'm pointing that out is because that's going to make the rest of the question a lot easier. We don't have to try every number after 4 one by one, because given our rainbow pattern, well, I know 4 times 4 gives me 16, and that means the next factor is going to be whatever 2 is multiplied by to get to 16. Right? I know that we are always going to have this pattern here. So my next factor will be whatever number 2 multiplied by gives me 16. And so 2 times what would give me 16? If you can figure that out in your head, that's awesome. If not, you can always count worst case, just to be sure. So if we count off by 2's, 2, 4, 6, 8, 10, 12, 14, 16. Okay, so it goes in 8 times. That means 2 times 8 gives me 16. All right. And then following the pattern, I know that the next one is going to be whatever 1 is multiplied by to get to 16. So 1 times what number gives me 16? That's right, 1 times 16. And since 16 is our original number, we know that's going to be the last factor. We also could have said, since we know 8 is half of 16, We know that that's going to be the second last factor, and the last one will be 16. Bunch of different shortcuts. If it's a lot of info, I apologize. It gets easier the more you do it, but the way that I would recommend doing it is just going up one by one until you get to the point where you have two factors multiplied together. In this case, it was two different ones. In this case, it was actually the same number multiplied by itself. I wanted to show you this so that if you're ever doing that on your own, you don't get confused. But once you get that first multiplication, then you just have to complete the rainbow and you have all your factors. Okay, so now that we have a bit of an understanding of what a factor is, let's look at a term that you are going to have to know on your GED Math exam. It is called the greatest common factor. So they may ask you to find the greatest common factor, also denoted as GCF. So if you ever see GCF, you know what that means, of 16 and 24. All that means is it wants you to find the biggest number that is a factor of 16 and also a factor of 24. Well, we already have all our factors of 24 and 16 written, so we just have to find the biggest number that's in both lists. Okay, so the biggest number in this list is 16, so let's start there. Do we have 16 over here? We do not. The next biggest is 8. Do we have 8 over here? Oh, we do. That was quick. Okay, so 8 is going to be our greatest common factor. You might say, well, but we also have 4. 4 is in both of them. And that's true. 4 is a common factor, but it's not the greatest common factor, right? Because 8 is bigger than 4. So we got to pick the bigger number. So our answer, the greatest common factor of 16 and 24, that is going to be 8. Now, that question was nice and simple because we already had our factors written out for 24 and 16, so we just had to look at the lists. But let's say they gave you a question where you didn't have that written out for you. Let's say they asked you to find the greatest common factor of 20 and 30. Now, you might be able to list in your head factors of 20, factors of 30, and just figure out what is the biggest one that goes into both. You might be able to do that in your head. But if you can't, that is totally okay. You don't have to be able to do that. And a good foolproof way to do this, even if you can do that and you just want to make sure that you're doing it right, is just again to list out all the factors of 20, all the factors of 30, and then just see what is the biggest number. So let's start with 20. Let's find all the factors of 20. All right. So, you remember how you do this? Well, we always want to start with 1 because 1 is going to go into any number. And then let's keep going one by one. What about 2? Does 2 go into 20? Well, yeah, 2 goes into 20. So 2 is going to be a factor. And again, if you want to make sure, I just know 2 times 10 is going to give me 20. But you could always count out by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, what about 3? Now, again, this is where I use shortcuts. So I know that 3 goes into 21. Therefore, it's not going to go into 20 because if I'm at 21 and I take 3 away, I'm going to go past 20. But if you don't have those mental shortcuts, that's okay. Again, you can always just count up by 3s and see if you get to 20. 3, 6, 9, 12, 15, 18, 21. So we pass it. So 3 doesn't work. What about 4? Does 4 go into 20? 4, 8, 12, 16, 20. It does. And how many times did it go in? It went in 5 times. So that means 4 times 5 is going to give us 20. Which means 5 is also going to be a factor, right? Because 4 times 5 is the same as 5 times 4. And, well, if 4 times 5 gives me 20, then that means I have the first layer of my rainbow. And that's good news because that makes the rest of the question a lot easier. I don't have to continue to go up one by one. I know that, well, 4 times 5, that gives me 20. So then the next factor is going to complete my next layer. It's going to be whatever 2 is multiplied by to get to 20. So 2 times what number gives me 20? If you don't know this, you could count up by 2's again, see how many times you have to go. but I just happen to know 2 times 10 gives me 20. And then the last layer is going to be completed by doing 1 times some number. And I know that 1 times 20 is going to give me 20. And so I get my list of factors for 20. They are 1, 2, 4, 5, 10, 20. Again, once you have your first layer of the rainbow, all you got to do is complete it. Nice and simple. Okay, so we got the factors of 20. Now we just need the factors of 30, and then we just find the biggest number in both lists. Don't know why I did a comma there. Wanted a colon. Don't you hate when you want a colon and you get a comma? Such a common problem. Haha. All right, factors of 30. Well, 1 is going to work. What about 2? Do we think 2 goes into 30? Yeah, I think so. You could always count up if you want to double check, but I know 2 goes into 30. What about 3? 3 is going to work. 3 goes into 30 because 3 times 10 is going to equal 30. What about 4? Well, we know that 4 goes into 20, so we don't have to count all the way up starting from 4. We can jump all the way to 20 and then just continue counting up by 4s, right? So 4 is going to go into 20 and then 24, 28, 32. Okay, so that doesn't work. What about 5? Does 5 go into 30? Well, again, we know 5 goes into 20, so let's start at 20 and count up by 5s. We got 20, 25, 30. Okay, that does work. So 5 works. And what about 6? I'm not so sure about that one, so let's count up by 6s. 6, 12, 18, 24, 30. Oh, it does work. And how many times did that go in? It went in 5 times. So 6 times 5, that's good news. Rainbow layer 1 complete. And now the rest of it should be a lot easier. So 3 times what number gives me 30? 3 times 10. That's right. And then we got to do 2. 2 times what number gives me 30? This is another way of saying what's half of 30? Whatever half is, if you take half and you multiply it by 2, you get the whole number. Well, half of 30 is going to be 15. And again, if you don't know that, that's okay. Just count up by 2s until you get there. That works as well. All right, 2 times 15. And then the last one's going to be 1 times the number itself. 1 times 30. That's the best way to do it, because if you just keep counting up 1 by 1 by 1 all the way to 30, you're going to have to try a lot of numbers, and it's going to take a lot of time. So once you get to that first layer of the rainbow complete, just complete the rainbow. I know, I sound like a Skittles commercial right now. I promise they're not sponsoring me. But complete the rainbow, and then you have your list of factors. Okay, so now that we have all our factors of 30 and all our factors of 20, to find the greatest common factor, I just need to find the biggest number in both lists. So let's start at the biggest end and go 1 by 1. 30 is in this list, 30 is not in this list. What about 15? Is 15 in this list? Nope. What about 10? Oh, 10 is in this list. Okay. So since I started at the biggest end and I worked my way down, I know that 10 is going to be the biggest number that is in both lists, because no number bigger than it was in both lists. Now, if you kept going, you would find 5 is also in both lists, 2 is also in both lists, 1 is also in both lists. So those are all common factors, but they're not the greatest common factor, right? Because 10 is bigger than all those numbers. So the greatest common factor of 20 and 30 is going to be 10.
All right, for intermission number 2, I'm bringing you a joke. Not just any joke, but a math joke. You ready for this? I'm ready. Okay. What did the triangle say to the circle? I know what you're thinking. He said nothing because he's a triangle and triangles don't speak. But this joke takes place in the land of speaking triangles. I should have given you that context. Anyways, what did the triangle say to the circle in this weird universe that we're apparently in right now? He said, "You're pointless." Get it? Because circles don't have points on it. When I was teaching in classrooms, I told one of my students this joke. He was like I don't know, maybe a 12-year-old kid. And he loved it. He found it really funny. And on my last day teaching that class, he came up to me. And because this was kind of an inside joke, he said, "Hey, Mr. So-and-so, you're pointless." And it was like an inside joke. He was referencing the joke that I had told him, but his friend who was with him didn't know anything about this joke. So all I heard him say was, "Hey, you're pointless." And he turned to him and he goes, "That's mean." It was so funny because he was like so ready to come to my defense. And I was like, no, it's okay. It's okay. It's a joke. Don't worry about it. Good times. Good times teaching math, because those do exist. Anyways, do what you need to do. Stretch your legs. Get a refill on that snack. I don't know what you're doing. And when you're ready, hit that play button and we will finish up with the last math question of the day. All right.
Alright, so now that we have looked at multiples and factors and done some practice with both of them, let's look at the type of question that you might see on your actual GED Math exam. You might see something like this. It says Mark and Andrew are running a race. They're very competitive people. And they also have very biblical names. Just thought I'd point that out. Andrew completes a lap every 3 minutes. He's really fast. Mark, not so fast. He completes a lap every 5 minutes, but that's okay. We're not here to shame Mark or anything. We're just here to solve some math questions. How long will it take until they complete a lap at the same time? All right, so Andrew completes a lap every 3 minutes, Mark every 5 minutes. How long until they complete a lap at the same time? So for a question like this, I think it's helpful to draw an image to help us visualize this problem a bit and what it's asking. So let's say they're running around this track. Doesn't specify what the shape of the track is, but it doesn't really matter. We're just dealing with how long it takes them to complete a lap, right? Regardless of what the lap looks like. Okay, so Andrew, let's say this is the start. He goes around this track every 3 minutes. So after 3 minutes, he'll be back at the start. After 6 minutes, he'll be back at the start. After 9 minutes, he'll be back at the start, and so on. Whereas Mark, he takes a bit longer. He takes 5 minutes. So after 5 minutes, he'll get back, and then after 10 minutes, he'll get back, and then after 15 minutes. And we want to know how long will it take them to complete a lap at the same time. So we want to know, when are they both going to be back at the start at the same time? Well, I would say let's list out all of the minutes where Andrew and Mark are going to be back at the start. So let's start with Andrew. We know he's going to be back at the start after 3 minutes, after 6 minutes, after 9 minutes. You might see something here that reminds you of something earlier in this lesson, right? What are we doing? Well, we're starting at 3 and we're counting up by 3s. Okay, 12, 15. So what's another word for what we're writing out here? These are all multiples of 3, right? We start at 3 and we count up by 3s. And so all we're doing here is listing multiples of 3. These are all the times that Andrew gets back to the start. And what about Mark? What do we think we want to do with Mark? Well, it takes him 5 minutes, so he'll be back after 5 minutes. He'll get back to the start. And then another 5 minutes. That'll get us up to 10. And then another 5 minutes will get us up to 15. Well, hold on a second. What are we writing out here? Starting at 5, counting up by 5. These are just multiples of 5. Okay, so I can keep going. And so I want to know, how long will it take until they're both completing a lap at the same time? Well, let's look. Do we have any common times here? We got 3, 6, 9, 12, 15, 18. For Andrew, these are all the times he's back at the start. And for Mark, we've got 5, 10, 15, 20, 25, 30. And so, well, let's look. 3, no, that doesn't work. What about 6? No, that doesn't work. What about 9? Nope. 12? Nope. 15? Oh yeah, look at that. After 15 minutes, Andrew's going to be back at the start. And Mark is also going to be back at the start. And so we could keep going and see if there's another time that they get back at the start. But it's asking us how long will it take until that happens. And so the answer is 15 minutes. It doesn't take any longer than 15 minutes because after 15 minutes, they're both going to be back at the start. And so the answer to this question is going to be 15 minutes. Now you might be able to do that whole question and not even realize what you did. But what we did there is we listed out all the multiples of 3, all the multiples of 5, and we found, what did we find? The least common multiple of 3 and 5. So that is an example of how you could use the skills that you learned today to help you pass your GED Math exam. If you see something like this, it's asking you to find the least common multiple of 3 and 5.
And that concludes our second lesson in basic math training. I know it was a bit of a lengthy one, but these are important skills, important information to know, and they are going to serve you for a long time as long as you continue studying and training for that GED Math. So this time was well spent, and future self is going to thank you for the knowledge that you now possess. You are one step closer to passing your test and accomplishing all of your dreams, and I just want to say I'm very happy with your progress so far. You're doing great, and if you stay on this course, there is no doubt in my mind that you are going to show the binary mermaid who is boss, and also ace your GED Math exam while you're at it, just as a bonus. So, good job. I am proud of you. I see the hard work that you're putting in, and I promise you it will be worth it, and you will get to that day where you pass your test and you graduate. You're so happy, and you get to reap the rewards of all the work that you're putting in now, all the hours of watching the Calculator Educator on YouTube. You're gonna get there and it's gonna be amazing, and you're gonna have the rest of your life to do whatever you want. So here's to your future, because it is bright. I promise you that. It is brighter than my lamp right now, and I'm telling you, my lamp is bright. So that's saying something. I am the Calculator Educator, coming at you with all the math info you need. I'll see you in the next video, saying 1, 2. I'll be seeing you. Hey, thanks so much for watching. If you enjoyed this video, make sure to hit that thumbs up button, and also make sure to subscribe so you don't miss a single episode. I am going to be covering the complete GED Math curriculum. As well, if you are somebody who is currently studying for their GED Math exam and you feel like you could benefit from some one-on-one tutoring, I am a professional math tutor, and I currently have some openings for some new students, so feel free to either leave me a comment, send me an email at calculatoreducator@outlook.com, or send me a message on Facebook where my username is, of course, Calculator Educator. I will post a link in the description. Again, thank you so much for all of the support. I appreciate it more than you know. I hope you have an amazing day. See you.